Thank you all for being with us. This is our first webcast in a series that we're going to have to celebrate the 10th year and 10th anniversary of Ocean Exchange. I'm not going to spend a whole lot of time talking about Ocean Exchange other than we are a 501c and we give away non-dilutive funds to startups through a competitive process. You're going to see my email address on several slides. And why don't we start the first slides, Blake? I do want everyone to know that we are recording this. It's going to be posted for anyone to see. So you're kind of duly notified about that. We'll take Q&A through this. There's a Q&A function as we go through. You can start putting your Q&A there and we'll address them one by one. I want to introduce the people that you see on the screen that you will see. And Blake DeChico is there. He's our intern that's helping us put this together. He's a Miami University of Ohio grad. He's on a hiatus from TV production. He was a production assistant with Will and Grace and a survivor, and he's with us during that hiatus. And many of you know Alice Spillman. She works with Ocean Exchange. She's our digital media person. This is our 10th year. We want to recognize our sponsors. Here are major sponsors here. You can find other sponsors on the website. We have some board members who are deep under the radar that you won't see their names, and they are also great supporters and financial sponsors of us. And we thank all of our sponsors. We can't do any of this without them. We're going to have a series of these. We're going to feature startups that have come through our process. Today, you're going to hear about two. Okay, Blake, you can switch that. You're going to hear about two that won monetary awards. And we have our friend David Hume from the Liquid Grid, who is with us as well. And he knows a lot about many things maritime. He's spending a lot of his time today on water power energy, but he's very passionate about all things maritime. If you don't subscribe to the Liquid Grid, which is his blog, you should. It's very, very informative. Keep going. Okay. Here's our agenda. Dane Dunstan is going to MC this. If you've attended Ocean Exchange before, you will know that Dane has been our MC in our physical event. He's joining us from Wimberley, Texas. He's become just a great friend. I don't know, Dane, you've done this 6 or 7 years for us in the physical Ocean Exchange event.
14.
And he's a jewel and a dear friend now, and he's become part of the Ocean Exchange family. We will have another physical event in 2021. In that meantime, we're going to stay in touch with you. We have now 9 completed years of fabulous startups that we want to showcase every month. So stay tuned to future dates. In Ocean Exchange, I've gotten to know quite a number of former admirals, U.S. Navy admirals. So I'm going to use this term, Dane. I'm turning the con over to you.
Thank you. Hi, everybody. How's everybody doing? You know, it's a pity that we're not going to be able to get together this year for the Ocean Exchange, but I think whatever happens in the future, more of these webcasts, why only see each other once a year when we can be doing this monthly or quarterly in between, I think would be a great idea. For those of you who were in attendance at the Ocean Exchange in 2018, you might remember something I shared at the time, and I want to bring it back up again. I had seen a picture of Europe from space at night, and what you saw looked like a representation of the human brain. It was like lines of jewels and diamonds in the light of night. It was just incredibly beautiful. It looked like a representation of the human brain. And then you could overlay that with a map of Roman roads. And it was an exact overlay. The entire neurosystem of European society was more than 2,000, 3,000 years old and went all the way back to the most ancient times of human interaction. And when you looked at that, it wasn't just an analogy of a nervous system. It was the neural pathways of human society. And along those pathways, we had commerce passing, we had ideas passing, we also had wars and murder and plagues passing. And those were the things that shaped humanity. But there were big, big dark parts of the map, of the photo, where there was nothing represented. And those were the oceans. And what was missing were the sea lanes and the places where maritime travel had completely expanded everything we knew about the world at that time and continues to do so. And when you think about it, in our lives, the ocean is invisible to us. We go to the beach, we see a few waves and we see some seagulls. Maybe way, way, way off on the horizon, we see a ship passing. But what's really there is invisible. Even if you fly over it, you see this sort of shimmering surface, but that's not the ocean. That's just a reflection on the top. Everything underneath it is invisible. And until we start to get in and study it. And that's what the Ocean Exchange is about. And that's what we're about today. In January, I got to spend some time at the Port of Los Angeles, which is an amazing complex. I was working with the leadership there for a few days. Biggest port in the Western Hemisphere. It's phenomenal. When you get that many ships into port, maritime commerce is no longer invisible. It's huge. The biggest things you've ever seen in your life. They are expensive. They put out a lot of emissions. They bring in things like invasive species and pandemics and all sorts of problems. And we have a guest here today who's going to talk about one way to mitigate that and solve some of those problems. My first ocean exchange was in 2013. And before it started, I was sitting in the front row and there was a young man from Norway sitting next to me, and we got into a talk. And before it had even started, as he told me what he did, I thought, oh, this guy's going to win. And I was sitting beside him when we had the award ceremony, and he did win. So I want to introduce my friend from Echo Subsea, Tor Osterwald. Tor? I think we need, there you go.
Hello, Dan. Can you hear me?
Yeah, how are you?
I am very well, thank you. The sun is shining in Norway, and I mean, you reflecting back, it was just like it felt on that day in September in 2013. It was a fantastic event to participate in, and I'm so impressed by these 10 years of, as you write, impactful years it's been. Yeah. Not only for Ocean Exchange to put in a stamp as a recognized place where you lift up and facilitate sustainable solutions, but for us companies that can come around from the whole world and join the family. And yeah, so it's very good to see you again, Dane, and also the rest of the group.
Great to see you, Tor. Well, for those who are not familiar with Echo Subsea and what you've accomplished, why don't you tell us a little bit about what you do?
Certainly. We have been through 12 years now developed eco technology for mitigating one of the big challenges in shipping, and that is biofouling. That is basically what touches onto a hull, grass that attaches onto a hull from a ship is wetted into a water and then continues to become a big problem as long as it sails, because it then increases the drag of the ship, increased fuel consumption and increased CO2 emissions.
I think we have some slides of yours that we can look at too.
Yes. Thank you very much. Should I just go through those then, Dave?
Absolutely.
Thank you very much. What you see here is actually us in a nutshell. You see to the left, that is us in this submarine painted black mobile purpose-built water cleaning machine, I would call it. To the right, you see one of our fantastic customers. That is Queen Mary II, the flagship for Carnival UK. And every day we are in ports now in the port of Southampton or in the ports in Northern Europe, giving them eco-friendly services while they are loading and discharging. So if you move on to the next slide, Blake, we can go where it all started. Because you mentioned Rome, and it wasn't built in a day, and so wasn't EcoSubsea either. This is actually 12 years ago. We started EcoSubsea now in 1st of May 2008. To the left in the picture, you see my brother and myself trying to show what the robot does, but the robot luckily does it much better than us. And in 2008, we were doing some research for the biggest shipping company in the world, A.P. Møller-Mærsk. Before that, we had been lucky to participate in developing some robotics for cleaning aquaculture nets. And we asked A.P. Møller-Mærsk if they saw a need for an environmental friendly service that could clean ships in the future. What the message back was quite clear. That was that in the future there would be a need for a service that can clean ships and is environmental friendly. And that means it can clean the grass that grows under the ship, but at the same time collect all the grass that is released. That it can clean the grass that grows under the ship without damaging the soft anti-fouling coating that is protecting the hull from fouling. And number three, a service that is safe, because there had been many challenges with man-held equipment on the water. 2013 was a special year for us. In 2008, we soon found that building a service that was environmental friendly for cleaning and capturing of the water, that was a huge technical challenging task. The US Navy had tried to solve this since the 70s. And it was almost like brushing your garage, but your garage was in outer space. So everything went everywhere. In 2012, we were finished with the prototype. And in 2013, we managed to clean 6 ships. In 2013, in September, we felt like the luckiest guys on the planet because we were nominated as finalists at the prestigious Ocean Exchange. And then when we eventually won the Orcel Award, that was a great milestone for us. Since then, we have developed, we then used 51 hours to clean a ship. We saw that that wasn't commercially viable. We needed to improve. The next 4 years, from 2012 to 2016, we used on developing the operation, lasting then from these 51 hours to clean now in 2016 a 200-meter long ship in 9.5 hours. We have been very lucky to also be working with then leading ship owners, because we found that, okay, so we developed something that could solve by using nature to solve a great challenge. We used hydrodynamics, then we used vacuum, like I've shown a little bit. But we've also been very fortunate to work with leading ship owners who have seen that this is important and that environmental friendliness will be important in years ahead. And you see some of them on the list to the left. And one of them is the sponsor here also, Wallenius Wilhelmsen Logistics, who's been a fundamental collaborational partner over these years. To the right, you also see that after winning the Ocean Exchange, we have been very lucky to receive 6 or 7 high-hanging international awards. And that is, I think, because many more have seen the same as the Ocean Exchange stands for, that the solutions for the future, they are hiding in the water and they're hiding in sustainability. If you take the next slide now, I can tell you a little bit more about the problem we're facing. So I just mentioned biofouling. Biofouling causes mainly one economic problem and two environmental ones. So number one is that, as I mentioned, the buildup of drag that happens as soon as the ship goes into the water. It forces the ship to use extra power to go through the water, and thereby it uses more fuel. Our customers report back now that they see about 10% savings from having their ships free of fouling. But this also means that it's not only 10% added to the fuel bill, the biofouling, it also means 10% additional CO2, NOx and SOx savings going up to the air. But the latter that was found, that was surprising, I think, to many in the shipping industry, it was something that you mentioned, Dave, initially. And that is alien invasive species. So last year, the UN came with a report that showed that 1 million out of 8 million species in the whole planet don't have the fundamentals to survive. The main reason why species are not surviving is because it's not because they're shot or killed basically directly. It is because there are introduced species from other areas that take over their food chain and their livelihood. In shipping, we have thought for many years that it was the main cause for the spread of unnative species from one part of the world to the other has been through ballast. But in New Zealand, for example, it turned out that 3% of introduced species came through ballast, where 69% or more were hitchhiking with biofouling that grows under commercial vessels. And what has happened then over the last years, and particularly since 2017, is that governments and countries have said, no, we want to see what's under the ship when you enter. So in California, in Australia, New Zealand, and several countries is working on it, they are now saying to the ship owners that you have to show proof of what are you doing with the biofouling on your commercial ship when it enters our port. This also has quite strange, strong consequences now, where we see New Zealand, 5th of March 2017, actually stopped the ship that was going to discharge there for 9 days and sent her off to international waters because she will not welcome back until she got clean. If we go to the next slide, we see another challenge, and that is that the current technologies for hull cleaning that you have worldwide still today is handheld equipment or robotic held equipment that has limited or no capture. And typically there are two main challenges. Well, when you clean a ship for biofouling, it is abrasive to the coating, so you take off microplastic and heavy metals. That is then reducing the lifetime of the coating and of course the efficiency. Secondly, because there is no or little collection of these equipments, you get a massive spread of alien invasive species in the ports where this is allowed. So then the natural consequence is that in more and more ports internationally, traditional in-water cleaning is being prohibited. And we are going now, if you look with the little long glasses on, towards a catch-22, where more and more ports says you cannot come in if you have a dirty hull. But on the other side, there is less and less places in ports where you can do traditional in-water cleaning because of the local pollution that it causes. Could you please go to the next slide? So this is our contribution to the cause. Here you see the cleaning station in the midst of the picture. And in a typical day in Southampton, we will welcome then, for example, the Queen Mary II to come into the port. We will have this mobile equipment shipped between ports, but also normal location, localize it, either midship when it's a big ship, or on a barge if it is a vessel that needs to be cleaned at anchorage, for example. This is supposed to be a self-supplied mobile unit. So it has a filtration process system where it takes care of all the biofouling that is being taken off the ship. It has a cockpit where there sits a person safe and drives the robot that is underwater. It has a launcher and recovery system, an engine, and a soft jet pump. And while the ship is loading and discharging, without interfering in the other operations, there is something going on underneath it. And if you go to the next slide, we can see what that is. That is the robot that goes back and forth, taking off softly the biofouling that clings to the hull. As a fun fact, I can mention also that it is designed after the Batmobile. And that is just because life is too short not to design anything after the Batmobile. But it's made by the guys who makes the most advanced robotics in the world, just design, and some great guys in Sweden who are experts on this field, and then makes the beauty which is placed underneath here, which is the clean and capture discs, to make them go back and forth onto the ship while the ship is loading and discharging. And continuously in this process, all water and waste is sent up for further processing in the mobile unit that you saw. And there the fouling is bagged up. And on a typical ship, we would use, as I mentioned, 9.5 hours to clean it. And it would bag up to 1,000 kilos of organic matter. And in Southampton, we are having a collaboration with Veolia. So we send it to them, this organic waste that was on the bottom of a hull, to their process plant where they use it as an ingredient in making biogas. So in biogas production. And thereby this grass that's normally slowing down and increasing the energy consumption of a ship is then used to make environmental friendly electricity for the surrounding households around the port. The unit is also driven only by electricity and water, and it has some soft jets that shoots water over the surface in parallel with it, so it's not deteriorating the paint that needs to be very nicely. So if you look at the next slide now, I can go a little bit into your introduction day and what we have been using time on since September 2030. To date, we have been cleaning about 595 more ships. And we've cleaned out from the oceans, from these surfaces, about 60,000 kilos of biofouling. Till date, and it is the ships who have the savings. This is importantly, because it's the ship owners who are sailing the ships. But to date, we have contributed to about 3 million tons of CO2 being saved that should have gone to the atmosphere. That means the annual CO2 emissions from all Norwegian aviation. But we have big goals, and we think it is fantastic to have developed these stations that we have. We have two now, one serving the south of UK out from our Center of Excellence in Southampton, and one serving the ARA area, Belgium and Dutch port in Rotterdam, Antwerp, and so on. And we have some good fundamentals now to do next step, and that is scaling up. We had an ambition to start that after 400 cleans, and then we built a second station, and now we are looking for financial collaborational partners and operational collaboration partners to build these stations in key hubs around the world. Because if you see to the right here, and it doesn't show very clear because we are covering the photo, but what it shows is that our ambition is to contribute to make Norway carbon neutral. We have an ambition of cleaning 20% of the world fleet. That is 10,000 ships a year. And that would mean that 1 million kilos of biofouling would be taken out of the sea every year.
Hey,
and
we've got a question from the audience. What does it charge? What does it cost to clean a ship's hull?
Well, you say for a 200-meter ro-ro, the cost is about $15,000 US. That gives you a rough idea. But it all depends on then the amount of kilos, the size of the ship, and if you can do it from the port side or if you need to go on a barge.
And is that, you said it takes about 9.5 hours on the average ship. How large is the actual robot?
It is 2 meter tall and 3 meter long. And that is just because you're cleaning typically half a football pitch in one go.
Yeah.
So it needs to be quite big to actually cover that size
Yeah.
of.
That's fantastic. Any other questions from anyone? So what I'd like to do is
Next slide, Blake. Go ahead.
yeah.
There's the contact info.
Thank you very much. Yeah, this is wrapping up the contact info, and our encouragement now is for anyone to get in touch, to contribute on the continuous adventure and joining the goal of making the planet a little bit greener and cleaner when we leave and when we can. So thank you very much for that thing.
Hey, Tor, two more questions. First of all, together, how does it adhere to the hull, and is it manually operated?
Yeah, good questions. It is two things that keep it to the hull. So number one, it has propellers that drives it onto the hull. As soon as we start this vacuum and hydro flow, it will actually have an under suction onto the hull and cling into the hull with 150 kilo under suction. And thereby the propellers from that point is basically just moving this cleaning devices back and forth under the hull.
We have a bunch more questions. I'm going to have to unfortunately jump ahead because I want to reach out to David Hume. You know, we talked about the ocean being invisible. It is not invisible to David. Very few people on Earth know more or have spent more time studying it. David, give us some context on why this is important, what they're doing, and then give us some general context on the maritime sustainability and why that's so important.
Sure, thanks, Dane. Can you guys hear me?
Yeah.
Yes.
Great. So if you want to pull up my slides there. While those are coming up, just want to say thank you very much to Ocean Exchange for having me on board here. This is a great opportunity, and I think what you guys do is wonderful. And as my slides are getting pulled up here, my name is David Hume, founder of Liquid Grid, which is an online marine clean technology blog. But I did work in the commercial maritime sector for a number of years as a marine engineering officer on very large commercial ships before becoming involved in marine clean technology, which is what I currently work on today. And these slides are coming up, hopefully. There we go. So today, I'm just going to give a quick overview and provide some context, as Dane said, just talk about what the maritime industry is and really how it uses energy. Particular emphasis will be on ships as I talk today. So next slide, please. Great. Oh, sorry, go back one slide. Great. So when we talk about the maritime industry, you know, writ large, it really comes down to two different things: ships and ports. It's pretty obvious for a lot of people, but just want to acknowledge that for the sake of this discussion. I will be focusing on ships for this presentation, but I do want to acknowledge that when we talk about the maritime industry, you can't just consider can't just consider ships in isolation. Ports are a big part of the puzzle as well. Next slide, please. So as Dane said, the industry is often out of sight, out of mind, but it is truly immense. It is probably the single most global industry I can really think of. So pictured here is a picture some of you might have seen already, but it's really showing all the major shipping routes, and the red lines indicate different voyages. Color density indicates frequency. So as you can see, ships are really what connect us as a global society. An often used statistic that I'm sure many of you have heard is that roughly 90% of all world commerce is carried by vessels. So in layman terms, that's a lot of stuff. Next slide, please. And so the industry has been around for a number of years. Depending on who you talk to, it probably dates back to 1600s. But within the last couple of years, the industry has been experiencing some significant change, largely from 5 different drivers, which I've labeled here as digitalization, automation, regulation, societal pressures, as well as market forces. So each of these has been exerting pressure on the industry and forcing it to change, allowing new technologies and businesses to get involved in what was traditionally a very incorrigible industry. For energy and emissions specifically, each of these drivers has a role to play in encouraging adoption of new technologies and fuels. But I'd say particular emphasis is probably being placed on regulation and societal pressures. That's really what's forcing the energy and emissions aspect of the maritime industry. Next slide, please. So here's a very, very simplistic history that tries to show the relationship between ships and energy. So sail was the original dominant quote unquote fuel, which was displaced by coal, which was then displaced by fuel oil, which is what we use today. So in order to corner markets and maintain supply chains, vessels have typically needed to honor delivery dates for their cargo. So this need to set determined schedules requires reliable energy. Wind can be fickle and unreliable at times. Coal can be carried with the ship, which makes it a little bit easier to set schedules, but it wasn't super energy dense, which means you need to carry a lot of it. Fuel oil has been very energy dense, it's transportable, and it's generally readily available across the world now. So it has worked very well for shipping industry. So looking across the full history here, we had about 300 years of sailing vessels, about 100 years of coal and steam vessels, and now we had about 100 years of oil. But where are we going next? That's the big question. Next slide, please. So to help answer that, I just want to point out, like, what are some of the major energy consumers on a vessel, to give you some context here. And here's some of the big energy consumers. So propulsion is probably the largest for most vessel types, and that's really what makes a ship move, obviously. Auxiliary machinery are things like pumps and motors and heaters. The hotel loads are things like the electrical and heating loads that keep the crew happy and sane when they work on the vessel. Cargo handling are things like refrigerated containers or cargo ventilation fans or lighting for cargo holds. And then the mooring and maneuvering are things like bow thrusters or anchor windlasses, etc. So these are major consumers on a vessel. Next slide. In reality, let's take that to an actual ship. So pictured here is a Maersk Triple E class vessel. This isn't the largest ship in the world. It used to be at one point, but now it's maybe slightly above average. Ships are continuing to get larger and larger. This vessel carries about 18,000 TEU, which is a way to rate the capacity of a container ship. So a TEU, for those of you who don't know, is a 20 equivalent unit, which is essentially a 20-foot container. Ironically or confusingly, most ships today carry what are called an FEU, or 40 equivalent unit, which is essentially 2 TEUs back to back. But this is a 18,000 TEU vessel, and it has 2 large diesel engines, which consume about 120 tons of fuel per day. Do we put out the poll question, Dane or Millie?
We can do that right now. Alice, why don't you open up the poll?
Oh, okay. So just real quick, if anyone's really good at math, roughly what does this equate to in terms of gallons? Hopefully you guys just got that pop up real quick on your screen. So while you guys are answering that, this roughly works out to about $75,000 a day in fuel costs for the vessel. And so, do we want to wait for answers to come in, or should we just move on?
Votes coming in.
I would say keep going, and when you're done, we'll look at the votes.
Great. So I'll give you the actual answer towards the end here. Oh. Sorry, a second. Okay. So moving on to the next slide. So these ships use a lot of fuel, but this isn't the same stuff you put in your car's gas tank. Ships have historically used what's called heavy fuel oil, sometimes also referred to as bunker oil. So I have a picture of what this stuff looks like on the far right. You can see that it's very viscous, looks like molasses, it's very, looks like pitch. And ships have historically used this stuff. It literally comes from the bottom of the barrel when it comes to fuels, and it's loaded with all sorts of nasty elements and compounds left over from the fuel distillation process, which I'm showing in the graphic there on the left. You can see it literally at the bottom there is where it says fuel oil. And so when you burn this stuff, not only does it create carbon dioxide when it's burned, but it also results in significant levels of sulfur oxide and nitrogen oxide, often referred to as SOx and NOx, which are dangerous local pollutants that can cause acid rain, asthma, among many other things. All nasty stuff that we don't want. So this is the fuel that's used. Next slide. But where is that fuel actually going? And this is where Tor's presentation comes into play. So ships use a lot of fuel, primarily for propulsion, but you can see that not all that energy is going straight to propulsion. A lot of it winds up as losses. So looking at the top left quadrant and the top right quadrant in this picture, you can see that a lot of that energy that comes from the fuel is lost. And hull friction is a big portion of that. So exactly what Tor's company is working on is trying to reduce frictional losses. By reducing that percentage of loss going towards friction, you're increasing the amount of energy going towards propulsion to get the vessel through the water, thereby getting better efficiency out of your fuel use. So in my mind, each of these losses really represents an opportunity for fuel and cost savings, which is exactly what some of the other presenters will be talking about later. So next slide. So why care? Well, climate change is a simple answer, in my opinion. Shipping currently emits about 900 million metric tons of CO2 each year. That's roughly similar to the emissions of the entire country of Germany each year, or 2 Canadas. So shipping is a sector which is difficult to decarbonize, and as other sectors reduce emissions in the future, hopefully, shipping could account for a larger percentage of total emissions if we don't alter course. So see on this chart, you can see we're around 900 million metric tons right now. And the business as usual case has us anywhere between 1,200 million metric tons in the future up to potentially as high as close to 3,000 million metric tons if we don't do anything. What's important to note here is that most ships are designed for operating lives of about 20 to 30 years. So while the end state in 2050 may seem far away, the ships that are entering service today are going to have to contribute to carbon reductions in the future. So we need to start deploying solutions rapidly, not in the future. Next slide. Fortunately, there are solutions and there are options. This graphic is stole from DNVGL, which is a maritime consultancy, and it highlights the need for a multi-pronged approach to decarbonize the industry if we want to meet international goals to reduce emissions by 2050. So there is an international regulatory body called the IMO, or International Maritime Organization, which sets a lot of these international goals and standards. They do have in place a goal to reduce maritime emissions by 50% by 2050, using 2008 as a baseline level. So as you can see here, there are a couple different high-level levers we could pull on, including logistics, energy efficiency, speed reduction, and fuels. So I think the presentations today are really touching on that energy efficiency piece, which is a big part of the equation. And then next and last slide. So drilling down just a little bit more, I like to show this chart because I think it shows the myriad ways that the maritime industry can decarbonize. So what you're seeing here is a box plot of different maritime decarbonization methods and their potential for CO2 reduction. So longer bars imply a greater uncertainty or range in their potential, so still a little bit unknown what they can actually do. And the bars that extend further to the right are stronger levers potentially. But more importantly, what I like about this chart is that it shows we're going to need a varied approach that relies on a lot of different tools and technologies if we want to make big reductions in emissions. We can't just rely on any one single technology. And so that's why I'm a big fan of Ocean Exchange and all the work they do, because I think green clean technology innovation can help get us there. And I'll stop there.
Hey, David, here's a question. How are we doing on reaching the IMO 2050 targets?
Depends who you talk to. So DNVGL, which is one of the major consultancies, thinks we're off track and thinks we still have a lot of work to do to get back on track.
Okay, here's the poll questions.
Great. So ranges are all over the map. So with the numbers I presented to you guys, which is around 120 tons of fuel a day for that particular vessel, that equates to roughly about 35,000 gallons a day. So I'll put that in perspective for everyone in relation to your car's gas tank.
That's great. Well, listen, David, stay with us if you would, because I want your opinion and your context on the rest, what we're going to talk. We're about to jump from really big ships to really small ones. Trawling nets have caused a lot of damage in our coastal waters and our coastal fisheries. And so it's really an issue that affects where we get our food, the future of seafood, a lot of important things on it. And a lot of fisheries have been closed or severely limited because the damage that nets do as they're dragged across the bottom of the sea. In 2017, we had a really interesting finalist come in. When I talk to the finalists, I sort of, as I'm coaching them, I say, look, the audience only wants to know 3 things from you. They want to know if I get what you're talking about, if it makes sense to me. We want to know, does it really, do I trust you? And finally, I want to know is, how do you make me feel? And this presenter hit all three of them. One of the best storytellers I've ever heard. He was able to tell us why his solution made sense, why it was important, what it did, and how it made everything better. So I want to introduce from Environmental Trawler Solutions, Randy Skinner. Randy?
Yes, hey, good morning. It's good to be here with you this morning, and I just want to say thank you for giving me the opportunity to be here today. And it's funny that we've been shrimping here this year, very minimum because of the virus, and we've had to use the trawl doors this year. And I have to say, it's not very fun to use trawl doors instead of wings. Now, if we go to the first slide that I've got you there, I want to show you the picture of the vessel that I have. This is our shrimp trawler that we're using. It's about 75 foot, and this has trawl doors on the end of each outrigger. Now, what we specialize in is saving fish. Now, if you go to the next slide here, I'll show you a typical tow that we have. Now, what we do, and this is not very easy, we're eliminating what you see is silver in this tow. Now, this is where we dump both nets on the deck of the trawler after we drug for about 4 hours. Now, you've been talking about fuel savings. We also have fuel savings with wing trawling system that have invented, and it's around 40%, which is, to us, is pretty substantial. Now, what we're doing with the wing trawling system, we're removing what you see silver as far as the fish in this picture away from what's brown, which are the shrimp. Let's go to the next picture here. Now, both of these pictures, these were taken about 6 months apart, both of them with trawl doors, both of them showing around 40%, most likely a bycatch of fish. And that's what we're trying to eliminate is the bycatch. It's not friendly. It's no need to catch it. We just throw it back. There's other marine creatures that eat it. Sea life, seagulls, porpoises. We feed all sorts of animals that follow the boat all the time. But with the wing, I'm going to go to the next picture, to the next slide here. Now, see, this is a wing trawling system that we invented. This is the final design. This is the one that we have pulled. Year before last, we pulled around 15,000 miles. This is what we pulled this piece of equipment. There's one on the end of each outrigger. Now, if you noticed earlier, we had trawl doors on the end of the outriggers. Typically, over the last 100 years, that's what has been used to spread open the trawl. When the trawl doors hit the water and you're moving at about 4 knots, they will open up, and then they will open up the net to the configuration that the wing holds it open. Well, the problem with that is that when you're pulling a trawl with trawl doors, you create what is called a herding effect out ahead of the net, and it's conducive for catching fish. Now, there's a big difference between fish and shrimp. Shrimp have a horizontal tail, and when they go to escape because they've been challenged in the water or something is after them, they will jump vertical. Now, that's because they have a horizontal tail, and that is their primary way of escape is vertical. Now, with finfish, and that is the silverfish that you saw in these pictures, that silverfish will swim either left or right. Now, if its trawl door is being towed, that fish is going to swim right, or he's going to swim left, and he's going to encounter a large trawl door, which is going to turn him back around. And eventually, he's going to weary out, and he's going to get captured. You can go and flip the slide one more time here. And this is the wing that we're deploying about to, and you can see it's very sleek in design. It's about 2 inches thick. So it's not a whole lot to frighten sea mammals away, you might say, but it's just enough pressure, just enough visibility there that even when you're towing at night, fish sense the metal frame that's being pulled in front of the net, and they swim left or right, and they escape capture. Now, with trawl doors, they would escape to the center of the net, and they would be captured and they would be caught. Let's go to the next video here, or the next slide. Now, do you see much silver in this? No, this is a toe that we made with the wing that you just saw. And if you notice, there's hardly any silver in it whatsoever. It targets shrimp, and that's what we're after. Now, I saw the news yesterday where North Carolina, there was an organization that challenged shrimping in the state of North Carolina, and they brought lawsuit not only against the state of Louisiana, but they also brought lawsuit against the trawlers, such as mine, for pulling nets that are conducive for catching fish, is because of the bycatch. And that's what we've done with the wing trawling system. We have eliminated the bycatch. So now we can tow, and we'll go ahead and go to the next slide. I think it's a video. And we'll just kind of watch this, make sure it's muted for me, please. Do you see much fish? Now, the shrimp are small this certain time of year, but you can see it's hardly any fish whatsoever within the capture zone that we had here. Now, you have to remember also that while we were towing this, and there's a good volume of shrimp here, these wings do produce shrimp very aggressively. They work very well. But as compared to the conventional trawl doors that have been around over 100 years, they do capture, or they do burn around 40% less fuel than the trawl doors. So they're environmentally friendly to use with the vessel itself. As far as the engine, everything lasts longer. If you're pulling fewer RPMs, that means your engine's going to turn more times, and it's going to last longer. And you can go to the next slide. I believe there's one more. Is there another slide, or is that it? Nope, that was it. Okay, but anyway, that's the wing trawling system. That's what we're doing, and we've had great success with it. It's proving to work in a lot of different areas, and so we've pulled it very much in the state of Louisiana, where the bottom is soft, and we've had good success with it down there. So I guess that's it for today.
Randy, we've got a question, and probably nothing we can do about it now. Do you have any underwater video of how this
Yes,
works?
I do. There was some, I believe it's some on my Facebook page, if I'm not mistaken. If not, I will post some today.
That'd be great to see. You know, one of the things with fisheries is we've got so many species that take a long time to redevelop. So we're out going after tuna and swordfish and that kind of thing, when we should be going after the smaller species like shrimp, which reproduce really fast and grow.
Now,
do you think that you're going to be able to turn this industry around before it all gets shut down?
I certainly hope so. We're going to try. North Carolina has the most problems in the country, it seems, right now. The wing trawling system would be a huge solution for that problem. The problem that they're having is the little silverfish that you saw in the videos. That is the target fish for sports fish. It's the speckled trout. They go and they eat the little silverfish. Well, if the shrimp boats capture a lot of them and kill them, there's no bait for the sports fish to eat. And so they have to relocate and they have to move on. And so it's us to just leave the fish there and leave them alive. We're not damaging.
Hey, Randy, we've got one more question. We've got a couple questions. We're losing you on your audio there.
Escape.
Hey, Randy, we have a question about the conservationist objection.
And then we're targeting shrimp.
Sorry, I didn't mean to interrupt you. Okay. What about the conservation objections to damage?
Okay, you have to repeat it. Yeah, the audio fell out.
Okay. Let's move on to this question.
Repeat the question.
What's the effect of the dragging? Can you just go over that again? Because someone had a question about the drag to the bottom.
All right, I'm not getting all your question.
The question was,
the trawl doors are with wing. The net itself,
yeah,
the net itself does not touch the bottom. Really, the only thing that touches the sea floor is the particular chain that the shrimp just damage our trawl doors because they're so heavy. And you pull them sideways across the sea floor, and they will almost be like a small dredge as you pull them. The wing, it flies 18 inches above the bottom. And so it has very minimal contact with the
Yeah, I've seen the video, and you don't even, you barely even see any dust
floor at all.
from it. All right, hey, and
No.
Carpenter has a question. How are you getting the word out about the wing trawler?
Well, last year and this year we've put a lot out by the word of mouth because we shrimp all the time. We're full time at it, and we shrimp it may be 30 or 40 boats around us at any time. And then whenever we go to the dock and they see the wings, it's visible. And we have a lot of questions and answers, and people wanting to experience it. And then plus two, they can come and go out on the boat with us and see it work in action.
All right.
And so we've done that quite a bit too. And it's kind of hard sometimes to overcome a tendency of, like, the trawl doors have been around over 100 years. They began being used with sail power. And so it's going to take a little convincing, you might say, for someone to pull something that's radical and different, even though it's much, much better.
Is it transferable to other species of fisheries?
Not fish, because it doesn't catch fish.
Okay.
It reacts on the natural characteristics of a fish to swim away from it.
Yeah.
And that's how it divides the shrimp away from the fish.
Well, we all love
Now,
our.
it can catch flounder. It can catch flounder fish up on the East Coast or West Coast, and that's primarily because that fish has a horizontal tail, just like shrimp. So it does a very good job at dividing the vertical fin fish away from the horizontal fin.
Hey, let me bring David in. David, what are your thoughts on this and how he could expand this?
Hey, it's a great question. I'll be honest, my expertise in the fishery side is a little limited, but this is one of those issues that keeps popping up in terms of how to reduce bycatch on vessels. And personally, I think this is an awesome idea. It's great to see someone working in this space and trying to address that issue. In terms of transferable technology to other areas, yeah, other species for sure. Other than that, I mean, yeah, kind of getting outside my skill area here, so maybe to stop there before I get myself in trouble.
Do we have an email for Randy? Is it on the slides? Anybody know?
We'll get Alice to put it in the chat.
Okay, great. We just had somebody asking for it. Any other questions for Randy? So, David, let me come back to you. As we're moving forward, we're doing so much work about sustainability of the oceans, and yet everything that we're seeing is not looking. How can I say this? It's not moving fast enough. How are you seeing the whole ocean sustainability problem?
Yeah, it's sometimes hard to keep a positive outlook on the fate of the oceans. Personal take there, but there is definitely hope. There are a lot of cool innovations popping up left and right, and in the startup ecosystem or innovation ecosystem, let's call it, I think there's a lot of cool new developments happening, especially over the last couple of years. So one of the things I've been tracking is the number of innovation hubs focused on marine clean technology. And just looking here in the US, which is a very myopic view, especially when talking about the oceans, but just here in the US and Canada to a lesser extent, there are about 30 different incubators, accelerators, clusters, or various organizations that have popped up purely to support marine clean technology, innovation, and entrepreneurial growth. So that's a lot of groups that are purely focused on trying to support innovation in this space. It is a well-known problem, and word is starting to get out about all the different kind of opportunity areas for folks to get engaged here. So I do think things are starting to change, and there's a lot of interest. As you said at the beginning, maritime industry in particular is out of sight, out of mind, but I do think that dynamic is starting to change, and it's starting to come to the forefront of many discussions, particularly around decarbonization and sustainability.
You know, it's a big area. I've worked a little bit with Wallenius Wilhelmsen and Roger Strevens, and I know that they're so dedicated to making these numbers, and almost all the big shippers are. The effect that that could have could be huge. We have a question here. What do you think about marine autonomy and the move towards autonomous ships?
Yeah, it's a great question. I know there's a lot of companies that are putting a lot of thought into that. There are a few projects or pilots underway or about to hit the water fairly soon. Still a lot of questions remain. I'm not sure if Wallenius Wilhelmsen has any autonomous projects coming up, but there are a few ones that are about to hit the water soon. My personal opinion is I think it still has a ways to go. I think we're probably, throughout some numbers, probably 5-10 years away at the very least before you start seeing any of these vessels get into regular operation, especially for deep sea. Near coastal, it might be slightly different, but it's still going to be a little while before we see widespread adoption on these. A lot of things to work out still.
Yeah. We have a question, and this is probably for Millie. Do we have a list of organizations that are accelerating ocean-related products or projects that could be posted? So Blaine Ross asked that. We'll see if we can get to you that. This is from Ann Carpenter, Dave, who you know. What are you seeing worldwide about shoreside emissions reduction programs other than California?
Yeah, it's a good question. California, I think, is very progressive here in the U.S. I think other states are starting to get on board. There are national specific emission standards starting to come into effect. Other countries are starting to get on the bandwagon as well. So there is a recent change that was passed by the IMO, International Maritime Organization, went into effect earlier this year. It's called the IMO 2020 Sulfur Cap, which is limiting the amount of sulfur allowed in heavy fuel oil. So it's not really targeting CO2 emissions per se, but it is essentially forcing vessel operators to reconsider what types of fuels they use on vessels. So that is more of a global industry regulation, which is forcing a lot of vessel operators to reconsider, essentially the fuels they use and start looking at other options as well, essentially like hybridization, marine batteries, LNG, biofuels, etc. But looking at other potential emission regulations across the world, and I see a lot of good work happening out in Norway. They're very progressive on all this stuff. Europe in general is just really kind of being a leader in this area.
We've got some late breaking news here for Randy Skinner. Bobby Lamont has a potential investor for you she wants to introduce you to. So we'll get that to you, Randy.
Okay.
Good luck with that.
Thank you.
We're getting a little later. Oh, wait a minute. One other. We've got somebody, another contact for you, Randy. Allison Myers have some people who are looking to design a harvester and want to know if maybe you can help. So we'll make that connection for you too.
Okay. All right. Thank you.
Everybody, great presentations. Randy and Tor, great to see you guys again. David, so great to have your thinking and knowledge in on this. And I want to hand back to Millie.
Thank you very much. Blake, if you can give me the next slide. So I want to thank Dane. You're great as always. We hope Dane is going to be with us on each one of these. And he remains a good friend. Next slide. We hope to have these once a month until the end of the year, and then we will assess, and we may continue to have them once a month next year. I think it's quite likely. I do ask for your feedback. You can contact me via my email or through the website. Any feedback on this, topics you'd like to hear about, feedback about this in particular, how we can do it better and make it more valuable for you. We will have our next one June 11th, probably 11 in the morning as well, but we'll solve that in the next few days. We're working on that one with a partner. It's called AUTM, AUTM. That is the professional association for tech transfer officers at the university level. And it's a key target audience for us. We want to reach them so that we as a society start reaching into these universities and get this great technology out of there and get it commercialized. We think too much is sitting on the shelf. So thanks again. Follow us on social media. Follow us, LinkedIn, Twitter. Call me. If you're new to Ocean Exchange, this is at least a taste of what we're about. We have a lot more to show you, though. Thank you very, very much. Next slide, last slide, Blake. And we'll leave that up there.
Thanks, everybody.